Hi, this is Ida Quita, and welcome to the walkthrough of the HackerRank C++ language track. In this episode, episode 1, we'll be going through the first two challenges. I'll walk you through how to solve each one and point out tips, pieces of C++ information, and errors you might encounter. Remember in each challenge to do your own work, even though I'm going to solve it for you. The walkthrough should show you what my process is, but you really need to do this yourself to get value out of each challenge. If you don't have a HackerRank account, create one now and find your way to the C++ language track. Please note that the website and all content from HackerRank is their copyright material, which I'm using for educational fair use purposes. You're looking at the HackerRank webpage, the dashboard. Click on All Tracks and the C++ language track. It should look like this, except all of your challenges will be green. These ones I've tried while I've been making these videos. Let's start with the first one. In every challenge we see, there's an objective. You should read it over. This time, all we're trying to do is output the string hello world to standard output. Standard output is where you can think of it as the terminal in some console-based application, but standard output. There is no input, there is only the output, and they show you what the output should look like. And in this case, they even give you the code to create it. In order to run the code, there is the Run Code button. When you run the code, it's actually compiling the code. It's using something called the C++ compiler to turn this C++ in this buffer that I'm pointing to into code that the computer can run. And then it runs it against a test program to make sure that it's producing the output it expected. As stated in the objectives, there is no input. Here's the output that came from the program, and here's the output that the test expected. So this passed. You could just simply hit Submit Code and move on, but that's not all that there is to learn from this. Let's see if we can do this a different way, and I'll point out a couple of things about the C++ language. Every C++ program needs a function called main. A main is a function is a block of code that returns a result. In this case, it returns an integer, an int. And the block of code is C++ statements surrounded in curly braces, as you see here. You can have actually 0 statements in the curly braces and have it be valid. So this is, in fact, the smallest valid C++ program. But it's not a valid solution to the problem because it doesn't output hello world the way the requirements state. In order to do that, we're going to have to add some more functionality. We're going to get that functionality by using include. Include gives us the definitions needed to access functions that are not in this file. In this case, the input-output stream functions that are part of the C++ standard library. Specifically, we're going to write to standard output, which is called std_cout. And to do that, we're going to use the streamout operator. So writing to standard output with the streamout operator, 2 less than signs, we're going to write the string hello world exactly as was described in the specification, including the exclamation point, and we have to end the statement with a semicolon. As I said, a function is a block of code returning a result. In this case, we're going to return the result 0, which from main tells the operating system that the program thinks it was successful. Let's run this again. As you can see, a completely different implementation gets the same result and is equally valid. And that's important to note. Hopefully, as we go through these walkthroughs, you'll find different ways to solve problems than the ones I show. But what could have gone wrong? Imagine I had forgotten that semicolon. Remember, every statement has to end with a semicolon, so now we don't have valid C++. The compiler is now looking at this and saying, hey, I expected to see a semicolon before return. It put the error on this line. But where's the mistake? The mistake is on the line before. This is an important pattern. Often you will see errors on one line reflect mistakes on the line before. The compiler looks at return and says, you know, I kind of figured you would have finished what you were doing above before I got this. And without that semicolon, we hadn't finished. So it's important to look both at the line where the error is reported and at the line above to see if the mistake may be there as well. Let's go ahead and run it now that we've fixed the mistake. Sure enough, it passes. We hit submit code. It says, go to the next challenge. Click next challenge, and you'll go to the next challenge you haven't solved. So let's go to that challenge. The input-output challenge, not surprisingly, is going to both read input that the HackerRank test framework is going to send to your program and write output, a result from the program. In order to do this, we're going to introduce a few new concepts without really defining them. We'll get to it, don't worry. The first thing we need to do is to find a place to store something we want the program to remember. These are variables. In this case, we have a variable called s. S is a name we're going to use as a place to store something we want to remember. But in C++, you can't just simply give the name of what you want to remember. You need to give it a type. What kind of thing is this? Well, I want C++ to remember a string for me, which is a series of characters. And I want it to be stored, given the name s. Down here, likewise, I want a variable named n, and the type, the kind of thing it is an integer. It stores one positive or negative whole number. The next new thing is input. Notice these arrows, these greater than signs. This is a stream input operator. You can think about the direction it's coming from Cin and to S. Well, when the operator looks and sees that it's got a string to write to, it says, aha, let me go get a string of characters that end with any white space, a tab, or a new line, and put that in S. Doesn't matter what's there, I'll just store that in S. And then it says, oh, I need to also read into an integer, so I'm going to look for digits, prefixed optionally by a positive or negative sign, but only digits. And the result of that will be stored in n. So when we're done with this line, S stores whatever characters precede the first white space, and n stores the digits that follow that white space. Similarly, cout, as we used it before, takes the stream output operator, again, kind of look at the direction. It would write the contents of S, it would write a space, it would write the contents of n, and then another symbol out of the IO stream is ENDL, which is simply new line. So what's this task? We're going to read three numbers from standard in and print their sum to standard out. Well, that seems pretty straightforward given what we've just learned. Let's go try that. Notice that the sample input says that the three numbers are going to be separated by spaces and that the output is just a single number. They've added a series of includes which give access to other functions, most of which are really not needed here unless you wanted to be adventurous. But the ones we are certainly going to use are IOStream. And it says enter the code here. Well, what do we need to do? The first thing we need to do is have a place to store the numbers we're going to read. They're integers, so I'll call them integers. I'm going to define, or as is usually the term, declare a variable called a. That'll be the first of my numbers. I don't have to do them one per line. If I want more than one, I separate them by a comma. So this is two more integers B, and C. So I have three variables, A, B, and C, each of which can store a single positive or negative whole number. Note that these don't have any value yet, and if I were to do mathematics with them, the results would be undefined. But that's okay in this case because the first thing I'm going to do is I'm going to read from CN. Notice I didn't include std : as I did for cout in the earlier example because of this line here. This says anything that starts with stud : I'm just going to treat like I already typed stud : This is not used as considered good practice in large programs, but in a small program like this, it's perfectly safe. However, I can delete this line as long as I include the namespace qualifier in front of CN. And what do I want to read into? Well, I want to read into A, and then I want to read into B, and then I want to read into C. And I end this line with a semicolon. Well, what do I want to write to? I want to write to standard out. And remember, that's the stream out operator. And what do I want to write? I want to write their sum. Well, I can compute the sum right here. If you want to add things together in C++, it has an operator. Not surprisingly, the plus operator. This adds A and B and then adds C to that. That result is then passed to standard out. And since that's what we needed to do, we can go ahead and return 0 that we believe we're successful. Let's go ahead and run this code and see if it works. The input was 127, our output was 10, and they expected to see 10, 10 being the sum of 1 plus 2 plus 7. Well, let's say, well, if we know all we need to output is 10, what if we want to cheat? And I'm just going to say, fine, the only thing I need to ever output is 10. Now, when I run this against the sample test case, it's going to pass. But what if I wanted to try different numbers? I can add my own custom input. In this case, I'm going to add 5, 10, and 20. They didn't have to be in increasing order. In fact, I'll put 5, 10, and 9. So 5 space 10 space 9 is going to be what the program is going to be run against. Well, the output we got was 10, which is certainly not the sum of 5, 10, and 9. So we know that this isn't valid. Another way we could know this wasn't valid is to push the Submit Code button. This now runs a number of test cases. Only the first one has the sum of the digits equal to 10, and so all the rest fail. So we certainly can't do this. Well, what if I didn't want to just simply discard this sum by throwing it to cout? What if I wanted to use it for something else? Well, I could also store it in an integer variable. We'll call it sum. It's a much better name than A, B, or C. It's descriptive of what we've got here. And we can set that here at the declaration line by simply saying what value we want it to be after an equal sign. Seems pretty intuitive. And then down here for output, we can say, oh, we're going to output the sum. This reads a little better because I'm getting the values I want to sum, I'm computing the sum, and then I'm outputting the sum. It may seem clearer to read, and in this simple case, it probably doesn't matter. But as you're writing code, you want to think about, is what I'm doing clear to somebody who's never seen my code before? Let's try submitting this against all the test cases and see what we get. As expected, we now pass all the test cases. It shouldn't matter, and it doesn't matter, whether we compute the sum and put it in a variable or whether we computed it and passed it directly to standard out. We pass the criteria, we're done with the challenge, and we can move on to the next. And that'll be next episode. I hope you'll join me, and I hope you found this useful. Bye.